Hello everyone and welcome to Division with Complex Numbers. So again, remember that when we have negatives underneath an even root, square root in particular, we are going to change those negatives into I squares. So change the negative underneath the square root to I squared and simplify when working with monomials. If you're working with binomials where you have a complex term in your denominator, then you want to multiply by the conjugate of your denominator. And remember, conjugates are the sum and difference of binomials. So the conjugate of A plus B is A minus B, and vice versa. Now, you can use a shortcut to multiply those conjugates. Or you can go the long way and multiply them all the way out by using the full distributive property or FOIL. Okay, so let's look at a few examples. Okay, first we have here the square root of negative 80 over the square root of negative 10. The first thing that I see is that 80 is divisible by 10. So I'm going to rewrite that underneath one radical. I'm going to change that negative with the 80 to I squared, and negative with the 10 to I squared. Then I'm going to simplify. 10 will go into 80 8 times, and the I squared over I squared would cancel each other out. So I end up with the square root of 8. However, the square root of 8 has a perfect square factor of 4, so I can rewrite that as the square root of 4 times 2, and simplify that by taking the square root of 4. So that gives me 2 times the square root of 2. Okay, how about this next example, the square root of negative 40 over the square root of negative 8. Again, I see that 40 is divisible by 8, so I can put those underneath one radical. The negatives I change to I squares. The I squares cancel each other out. 8 goes into 40 5 times, so it gives me the square root of 5, which cannot be simplified, so that's my answer. Okay, how about 4 over I? Well, we don't want to leave an I in our denominator, so if we can make that into I squared, then we know it will change into the number negative 1. So let's multiply by I, because I times I is I squared. Now remember, whatever you do to your denominator, you need to multiply the same thing in your numerator. So let's multiply 4 over I times I over I. Now my numerator, 4 times I is 4I. In my denominator, I times I is I squared. Again, the whole reason we wanted to make that into I squared is because we know that I squared is equal to negative 1. Then we can simplify that a little bit more. 4 divided by negative 1 is going to be negative 4I. Okay, what if we have 7 over 4 plus 3I? So this time we have a binomial in our denominator with a complex term. So to get that complex term out of there, we want to multiply by the conjugate, which is 4 minus 3I. So in our numerator, we will use our distributive property. In our denominator, we're going to use our shortcut. So 7 times 4 is 28. 7 times negative 3i is negative 21i. In our denominator, since we have a plus b times a minus b, I will do the first term squared, 4 squared, minus 3i squared. So 4 squared is 16. 3i squared is 9i squared. Remember, I squared, not underneath the radical, is negative 1. So we have 16 minus 9 times negative 1, which is 16 plus 9, or 25. Now, we want to write our answers in a plus bi form. So we need to separate this into 2 fractions. So we will write this as 28 over 25 minus 21 over 25 times I, so that we will have that in a plus bi form. Okay, let's look at a couple more examples. All right, we have 5 minus I times 3 minus 2I. So again, we have a binomial in our denominator, so we want to multiply by the conjugate, which would be 3 plus 2I. Now this time in our numerator, we don't have a special rule that we can use. We don't have any squares for the special rules, so we have to use FOIL, or the full distributive property. So I will distribute the 5 to each one of those terms in the second parentheses there, which gives us, sorry about that, which gives us 5 times 3 is 15. 5 times 2i is 10i. And then distribute the negative 1i to each one of those. So we'll change both of those signs, become negative 3i. And negative 1i times 2i, negative 2i squared. Now, in our denominator, we can use one of our special rules. First term squared minus the second term squared. All right, so we know that I squared is negative 1 here, so that will become positive 2. And 15 plus 2, combining those like terms, gives us 17. 10i minus 3i gives us positive 7i. In our denominator, 3 squared is 9. 4i squared. Again, I squared is negative 1. So negative 1 and negative 4 makes positive 4. And 9 plus 4 is 13. So we want our answers written in a plus bi form. So we want to separate this into 2 separate fractions. So 17 over 13 plus 7 over 13 times I. Okay, and the final example, 16 plus 15i, all divided by negative 3i. Now, in our denominator this time, we do not have a binomial, so we do not multiply by a conjugate. We just need to make that I into I squared so we can change that into -1. So if we have just a monomial down there like that, we're just going to multiply by I. So we can change the I into I squared. So let's use our distributive property in the numerator. So that will give us 16I plus 15I squared. In our denominator, we have -3I times I, which gives us -3I squared. So again, I'm going to go in here, find those I squares, and change them into -1s. So 16I plus 15 times -1, -3 times -1. All right, so that's -15. Let's write that in front. -15 plus 16I, all divided by +3. And again, we want that in A plus BI form, so we need to separate the fraction. So we have -15 over 3, which is -5. And then we have 16 over 3 times I. Okay, I hope you found this video to be helpful. Thank you.